Hello students, welcome to my lecture on computer graphics. I am Shravani Kundu, Assistant Professor, Department of Computer Science and Engineering, Guru Nanak Institute of Technology. In this lecture, I will discuss the algorithm to generate the ellipse. After showing the different steps of the algorithm, I will solve a problem and I will show you how the algorithm executes step by step. So first we will discuss the algorithm. We will write down the algorithm. In my previous two lecture of the lecture on ellipse generation technique, I shown you how to derive the different decision parameters. So now based on those decision parameters, we will write down the algorithm to generate the ellipse. So we will start. So this is the name of the algorithm is midpoint ellipse generation algorithm. Ellipse generation algorithm. Okay. So this is the name of the algorithm. Now I am writing the step by step. So at step 1, what we have to do? We have to take the input. We have to take the input from the user end. So what the input we will take? We have to take the detailed parameters of the ellipse. That means the center of the ellipse, so which is called the XCYC. So we need to input the two, we need to take the input as a center of the ellipse. Apart from that, we have to take the length of the major axis, which is A, the length of the minor axis, which is B. Okay. And based on that, you have to compute the starting point. So this is the input step. At step 1, we have to take the input from the user end, where XYZ is the center point of the ellipse, A is the major axis, and B is the length of the minor axis. Now, in step 2, what we will do, from the step 2 onwards, we will calculate the points for the region 1. So as I shown you in my previous lecture, if you consider this is an ellipse, so for this ellipse, so if those are the axes which is passing x-axis and y-axis, and while we will compute everything, we will consider that the ellipse, center of the ellipse is 0, 0. Okay. Now, while we will consider this thing, then there will be another points which on the arc of the ellipse. So this point divides the ellipse in the first quadrant of the ellipse in two different regions. So one is region 1 and another region 2. So this is a point. These points divide the entire ellipse of the first quadrant, the entire curve of the first quadrant in two regions. This is region 1 and this is region 2. Fine. So now what we will do from the step 2 onwards, we will first compute the points on the region 1, and then we will write down the code how to find out the points for the region 2. Okay. Now in the step 2, what we have to do? We have to compute the initial decision parameters, which is called the P0. Now, as you know that whatever may be the center of the ellipse, to compute all the points on the perimeter of the ellipse, we have to bring the ellipse to the origin. That means the center of the ellipse will be the origin. So based on this, if the center of the ellipse is the origin, in that case, the P0 will be, and if we consider that A is the length of the major axis and B is the length of the minor axis, in that case, we will consider P0 is equals to B square minus A square B square plus 1 by 4 A square. So where A is the length of the major axis. So this is A and B is the length of the minor axis. Okay. So this is this entire length is A and this entire length is B. Fine. Now, in my previous lecture, you can find how we can get this equation. So we have to compute the P0. Now, so this is all about the step 2. Now in the step 3, what we have to do? As I told you that we will compute the points for the region 1. So we know the P0. We will write the step 3 in generalized form. That means in terms of the K. So here we consider, we will start with the value of K is equals to 0. So now we will check if Pk is less than 0, then the next points on the ellipse will be x of k plus 1, comma, x of k plus 1, you know, x of k plus 1, comma, yk. Fine. And after doing so, after taking the decision about the next points, you have to compute the decision parameter for k plus 1th iteration, and which is for the region 1. Okay. So the decision parameter for k plus 1th iteration will be pk for the region 1 plus 2b square x of k plus 1 plus b square. Okay. So you also again you can find how this equation, how we can derive the equation in my previous 2 lecture. Fine. Now after doing so, in the next step, so in this step, so if pk is less than 0, we will do this thing. But if pk is greater than 0, then what will be the next point? The next point will be xk plus 1. So better I can write it. The next point, that means the point x value for the k plus 1th iteration will be the x value at kth iteration plus 1, and the y value for k plus 1th iteration will be yk minus 1. Okay. Now based on this value, again we have to compute the decision parameter for the k plus 1th iteration, and which is for the region 1. So better we have to write it P1, and this is Pk of region 1. Okay. Now, and this is also P0 for the region 1. Now we will compute the P of k plus 1 for region 1 if the condition, if the value of the Pk is greater than 0, then how to compute the P of k plus 1? We can compute it by this equation, P of k for the region 1 plus 2b square x of k plus 1, and you know what is the value of the x of k plus 1, minus 2a square, and then y of k plus 1, and you know what will be the value of y of k plus 1, which is yk minus 1, and then plus b square. Okay. Now after taking the decision, after doing all the if, come out from the if. So this is one if statement, this is another if statement. Now outside of the if statement, you find out the component 2b square x of k plus 1 and 2a square y of k plus 1. Fine. Now after finding this decision parameter, as I shown you that this is nothing but the slope of the tangent which we can draw from the point, from this point. So let us say, let us give it a name. This, consider the point is Q. So for this, on this point Q, if we draw a tangent, then this is the value of the tangent, so dy by dx. Now if the value is less than, so when we have to stop the generation of the point, we have to stop the generation of the point if the dy dx is equals to 1. Okay, so what we can write? So all the steps, that means continue the step 3. So step 3 will continue until 2b square x. Okay, so this parameter x means this x of k plus 1. Okay, greater than equals to 2a square y. Fine. So I have to repeat the step, and when this condition will violate, we will come out from the step 3. Now in our step 4, what we will do? In our step 4, we will find out the points for the region 2. So far we have detected, so here whatever the points detected, these 2 points, so these points and this one, these 2 points, those are the points for the region 1. So those points belongs to the curve on the arc of the ellipse. Now if you have the center of the ellipse xc which is not origin, in that case, after generation of this point, what you can do, you can plot the points by shifting the coordinate with respect to the center of the ellipse. So just, it is very simple, you have to add it, xc plus this one and yc plus this one. So we will do the entire thing. We will assume that you have calculated those points and you have stored the point in somewhere else. So in the step 4, what we have to do? We are generating points for region 2. Okay, so here we have to write P0 for the region 2, initial decision parameter, and which will be nothing but b square. Okay, so this x0 is what, b square, this x0 plus half whole square, x0 is the starting point, plus a square y0 minus 1 whole square minus a square b square. Now what is the value for the x0? This x0 and y0 will be calculated based on the points of the last point of the region 1. Okay, so this x0 y0 can be calculated based on the points of last point of the region 1. So we are writing this x0 y0, which, what is x0? So the point, the last x, what is x0 y0? x0 y0 is the last point calculated in region 1. Fine. Now in our step 5, what we will do? Now we know, we get the initial decision parameter. Now we will find out the points on the arc of the region 2. So to do so, again we have to do the same thing. We initialize the value of k is equals to 0, and we will check if pk for the region 2 is greater than 0, then the next point, the next point which we need to plot on the ellipse will be x of k comma y of k minus 1. Okay. Now based on this point, you compute the decision parameter for the region 2. So what the decision parameter? It will be, we have to compute the decision parameter for k plus 1th iteration. So we will write it down. P of k for the region 2 minus 2 square y of k plus 1. So you know what is the y of k plus 1? Y of k plus 1 is here, nothing but yk minus 1. So I'm writing it, otherwise you can make the mistake. So y of k plus 1 is the k plus y value at k plus 1th iteration. So here you remember y value for k plus 1th iteration is nothing but yk minus 1. Okay. If pk is greater than 0, otherwise, so instead of writing another if, you can write otherwise the next point is x of k plus 1 comma y of k minus 1. So that means x value for k plus 1th iteration is xk plus 1 and y value for k plus 1th iteration is yk minus 1. Fine. Now what you can do, you take this point and based on that, so if you got the point which has to be plotted on the arc to get the ellipse, and we will compute the decision parameter for k plus 1th iteration for the region 2. So under this else part, we will write p of k for the region 2 plus 2b square x of k plus 1 minus 2 square y of k plus 1 minus a square. Okay. So this is my else part and this is the if part. And how long we have to continue? We have to continue step 5 until x is less than equals to 0. Okay. Fine. So now we determined the points for the region 1 and the region 2. So we know we got the points for the region 1, we got the point for the region 2, and we can compute the, based on these points of the region 1 and region 2, we can decide that what will be the points for the others region. Okay. So in the next step, that is in the step 6, what you have to do? So we got all the points for the region 1 and region 2. So subsequently we can compute the points for other regions. So we have to write determine symmetric point for other 3 regions. Okay. Okay. Another thing, just I made one mistake. So I just wrongly written it. It will be not X, it will be Y. Because we are decreasing the value of y, so not the value of x. So we will start from the end point of the region 1, then we will try to compute all the points. We are increasing the value of x and we are decreasing the value of y, and when the value of y will be value of y is less than 0, then that means when basically not less than 0, you also can say if the value of y is equals to 0, I have to stop. Okay. Now, so this is the stopping condition for the region 2 and this is the stopping condition for the region 1. So now you got all the points on the ellipse. So in the last step, that is in the step 7, what we have to do? We have to move each point calculated so far with respect to I should write WRT with respect to the center point XCYC. And how we can do it? Very simple. You just write XC equals the points, the plotted point, the point which I need to plot. That point is nothing but XC plus X. And the point of Y which I need to plot, the value of Y will be YC. It will be YC plus Y. And we need to plot X comma Y. So you got, after getting all points on the ellipse, you just perform this operation step 7, apply this operation XC plus X and YC plus Y on all points which you got on the ellipse. So to move your ellipse as per its original center point. Okay. So that is all about the midpoint ellipse generation algorithm. Now, I will show you how to solve the problem based on this algorithm. So, I will show you the problem. So, consider you have the length, you have an ellipse whose length of major axis. So here A is I am writing the length of major axis is equals to 8, and that means the value of A is equals to 8 and the length of minor axis, which is nothing but B, is equals to 6. Okay. And consider the center point, center of the ellipse, that is xc yc is nothing but 0,6, somewhere there. So what we have to, so those are the inputs is given, and based on the input you have to compute the points on the ellipse. Okay, so what we will do now, first we will compute the decision parameter for the region 1. So we can write it, P0 for the region 1 is nothing but as you can see from the algorithm, it is b square minus a square b square plus 1 by 4 a square. So you put b is equals to 6, a is equals to 8, and you can calculate the value. So if you calculate the value of P01, you will get the value minus 332. Okay. So simply what we have done, we put the value of a, b in the equations which is given for calculating the initial decision parameter for the region 1. Now what we have to do, we will make a table. So here k is my iteration number, pk is the initial decision, pk is the decision parameter for the region 1. Then compute the value of x of k plus 1, y of k plus 1. Okay, and we have to, as we have to, for the region 1, I can stop if this condition, if these two conditions get satisfied. So definitely we have to compute 2b square x of k plus 1 and 2a square y of k plus 1. We have to compute these 2 points also. So those are the different things we have to compute for the generation of the points of the region 1. So if you write down this thing in the form of table, it will be easy for you. So we'll start from k equals to 0. So P0, what is the P0? Minus 332. So is less than 0. So you can see if it is less than 0, the next point is xk plus 1. So x, what is the initial x? What will be the initial x? Initial x will be, so here you can see we will shift the ellipse in terms of the origin. The center of the ellipse will be shifted in terms of the origin. So if you shift the ellipse in terms of the origin, so this, what is my value of b? B is 6 and the a is 8. So this is the initial point. So what will be the value of the initial point? Initially it will be x value is 6, 0, y value will be 6. Okay. So what we have to do, so xk is 0 and yk is 6. So from here we can write xk, that means x0 is 0 and y0 is 6. Now what we have to compute? We have to compute x1 and y1. So what is x1? We have x1 is xk plus 1. Xk plus 1 means 0 plus 1. And yk plus 1 will be, what is the value for the yk plus 1? It is yk. Okay, so what we will do, we will keep it as it is 6. So the next point we need to compute is 1,6. Again, we follow the algorithm. We compute the initial decision parameter. So we done this part first. Then we are in k equals to 0. We are checking it is less than 0, satisfying. We are incrementing the value of xk plus 1. The initial value of the xk is 0, so it will be 1, and yk is 6, so it will remain as 6. So just we have written 1,6. Now you have to compute to b square x of k plus 1. So b, value of b is 6, so 6 is a 36 to 72 multiplied by 1. Okay, so it will remain as 72, and this is 2a square. A is 8, 64 plus into 2, it will be 128. 128, value of yk plus 1 is 6, so if you multiply 128 by 6, you will get the value 768. Fine. Now for the next iteration, that means for the iteration 1, based on those value, you have to compute So based on the value of xk plus 1 and yk, you have to compute the p of k plus 1. Okay. So if you compute the p of k plus 1, what you will get? You will get minus 2 to 4. Okay. And then this point will be 2, 6. Again, less than 0, y will be x will be incremented by 1, but y will not be incremented by 1. Okay. Now you have to compare 2b square xk plus 1 and 2a square yk plus 1. So if you do so, you will get the value 144 and 768. Fine. Now, for the next iteration 2, if you do so, you will get the value minus 44. And again, using the same logic, you can compute it will be 366. You just follow the algorithm and do it as your own, by your own. Then in my next iteration, that means in the third iteration, it will be 208. Again, it is positive now. Now it is positive means greater than 0. So x will be incremented by 1, x will be 4, but y is decremented by 1. So y will be 5. Okay, so next point is 4, 5. So based on that, you compute these two values. So it will be 288 and this point will be 640. Fine. Now, here you have at the next iteration, that means at the fourth iteration, again you have to, based on this, so once you got this value positive, so you have to compute the value of pk plus 1 based on this equation. So if you put the value accordingly, you will get the value for the fourth iteration of pk plus 1 is minus 108. Okay. So again it is negative, so only x will be incremented by 1, but y will remain as it is. So it will be 360 and it is 640. Now in the fifth iteration, again it is negative. Okay, so as it is negative, so based on that you have to compute the pk plus 1 using this equation. So if you put the value to calculate this equation, you will get the value 288. Fine. So 288, it will be 6, 4, 432 and 512 if you compute it. Now in the sixth iteration, as it is positive, so you have to compute the value of pk plus 1 based on the equation which is given. So if you compute it, then you will get 244 and the value is 7, 3. Okay, and what is the value we have got now? We got it is 504 and 384. Now you can see so far the value of this one. So as per the decision, we have to when the value of 2b square xk plus 1 is greater than this one, then we can continue. So far up to fifth iteration, the value of 2b square xk plus 1 and 2a square yk plus 1 is greater than this portion. The first value of the first portion is greater than the value of the second portion. So we continue. But after reaching the sixth iteration, you can see the value of the first portion becomes greater than the value of the second iteration. So as per the decision, I have to stop. Okay. So when this condition will not satisfy, so this is the condition for stopping. Again, I am telling, so before that, before the sixth iteration, you can see the value of 2b square. So this portion, the value of this part is always less than the value of this part. Okay. So this part is less than this one. So less than means we have to continue as it is given until. So as it is less than, we will continue. But when I will reach over here, I have to stop. So I can generate the points for all the points of the which belongs to the region 1. Now what we have to do? We have to compute the points for the region 2. Okay. So what is my initial points for the region? So we are computing for region 2. Okay. So as I told that in the region 2, the x0, y0 is the initial decision parameter and points, and which will be calculated from the last point of the region 1. So this is 7, 3. So here the starting point will be, so what we can say, x0 is equals to 7 and y0 is equals to 3. Fine. So again we will repeat the same thing. So we will write down k. We will write down pk for the second iteration. We will write down the xk plus 1. We will write down the y value for k plus 1th iteration. Then we will compute this thing 2r square. That means it will be 2b square x of k plus 1 and 2a square y of k plus 1. So this is 0. If you put this one in this equation, in this equation, you can get the initial decision parameter, which is p0, and the value of p0 will be minus 157. So as it is less than 0, so as the value will be less than 0, the next x will be x will remain xk and y will be decremented by 1. So x is 7. Okay. Sorry. If it is less than 0, we have to consider the second one. So if it is less than 0, x will be incremented by 1 and y will be decremented by 1. So x will be 8 and y is decremented by 1. So y value was 3, it will be 2. Okay. And we have to compute based on the value of xk plus 1 and yk plus 1. We have to compute those things. So we will compute it and you get the value 576 for here and 2556 here. Now in the next iteration, again, as this section, the else part satisfied. So based on the else part, we have to compute p of k plus 1. So if we put 8 and 2 and the corresponding value of a and b in this equation, you will get the p of k plus 1, and which is 233. Fine. So again, it is greater than 0. That means the first portion I have to consider. That means the x will remain same and y will be decremented by 1. So x will be 8 and y will be 1. Okay. You can compute the value of this portion. Basically, this is not required here. As you are writing the common code, you can generate it, but this portion is not required. You can omit it also. So in the second iteration, we have to compute the value of p of k plus 1 from the previous iteration. So as it is greater than 0, okay, so greater than 0 means this part. So based on this equation, we have to compute the next one. If I put 8, 1 in this equation on the corresponding value of a, so we got the value 745, and 745 means x will remain as it is, but y will be decremented by 1, so y will be 0. So y, now as y is 0, that means y 0 means we've completed the computation of these points. That means all points is computed. Computation of all points has been done. Okay, so stop as per the decision. If the value of y, you can see where it is given here. So if y is equals to 0, we have to stop. So that means we got all the points for the region. So those are the points for the region 2. So you got the points for the region 1, you got the points for the region 2. You successively can compute the points for the other quadrant and the regions for the other quadrants. And as the center is 0, 6, so what you have to do after computation of all this value, so I'm just showing 1, 2. So this is the first point, it is 1, 6. So the actual point is computed on the ellipse is 1, 6. So but where we have to plot it? We have to plot it at 0.1, 6.6, as the value of the center is 0, 6. So we have to plot the point at this position. Then we have to plot the next point. So what is our next point? The next point is 2, 6. So we have to plot the next point 0, 2, as the center value is 0 and this is 6. So in this way you can plot all the points. Clear? So that's all for the today's lecture. Hope it is clear to you. And if it is not clear, if you have any query, what you can do? You can watch my previous video, then you can understand why all the equations are there. Thank you for watching my video.